Hi everybody, this video we're going to solve a sum of the integral of the sine functions. Do not worry about the sum and integral together. In most of the cases, you can swap the position between the sum and integral. And then we will focus on solve the sum of k equal to 0 to infinity. Let's focus on the sum of the sine power 2k. So this one, when k equals to 0, sine power 0x plus when k equals to 1, sine power 2k, which is 2x. When k equals to 2 becomes sine power 4x, and so on and so on until infinity here. So obviously this is a geometric series where the first number is sine power 0x, which is equals to 1, and then the common ratio, as you can see, every time goes to the next value, it powered by sine power 2x. Therefore the s infinity of this is actually a 1 minus r, which is 1 over 1 minus sine power 2x. So replace this into the sum here. So we have, the question is transforming to integrate 0 to pi over 3 1 over 1 minus sine power 2x dx. The most popular identity is sine square plus cos square equals to 1. So here become 1 over cos square x. And then we know cos square is actually secant power 2x dx. In one of my previous video, I discussed the integrate of the secant power 2x dx, which is tangent x from 0 to pi over 3. Replace the x, become tangent pi over 3 minus tangent 0. Tangent 0 is a 0, and tangent pi over 3. Pi over 3 is 60 degrees, which is square root of 3. Therefore, the conclusion is sum of k equals to 0 to infinity of integral 0 over pi over 3 sine 2k x dx is square root of 3. In future, I will create more video to discuss about the sum and the integral. When can we swap, when we cannot swap. Thank you for watching. Don't forget to subscribe to my channel and click on the bell notification button. Bye bye.